Hello everyone, this is an assignment 1 on software quality assurance testing done under the guidance of our Professor Peter Sigurdsson, and we are the team Sunshiners. Our team members are Naveen, Anusha, Vashini and myself Vidya. Today we will be covering the following topics for the day. So that is software testing and the attributes of them and a few of the differences between them, and we are going to see few of the models as well and the testing methods used to do so. So let's quickly check on the introduction. So what is a software testing and why is it important? So software testing is a process where we evaluate the functionality of a software and check each and every requirement or the feature of a software is working fine. Next, we have a few of the applications of the software testing, where we check for the cost-effective development, product improvement, test automation and quality check. Under quality checking, we see the functionality, reliability, usability, efficiency, maintainability and portability. Software quality assurance is abbreviated as SQAP, and it contains the following processes of collecting the requirements, and then they see the prototype, design, test planning and deliver and the support. Next, we have the agile and unified processes, which is a very important process, and this is used in the IT world nowadays. So this is one of the most popular methods. In this, we have the user stories, requirement documentation, use cases, unified modeling language diagram, and software objects and the code and the data tables. Next, we have a few of the essential elements of the software quality assurance which are listed. One is the security, the error collection and analysis, and a few more to name. Then we have the document that it consists of. It consists of the purpose, reference, software configuration, problem reporting, tools and technologies, code, and the records. We have the functional attributes, operational attributes, usability attributes, business attributes, and instructional attributes. So in this, we see the characteristics of the input-output behaviors, the operational conditions, and how the software product works. And we characterize the cost of developing the software and see the internal structure of the product. Next, we have the methods of testing. So here we basically have two types. One is the white box testing and other one is the black box testing. White box testing, it's done by developers, and it is the detailed investigation of the internal logic and the structure of the code. And black box testing is done by our testers, and they do not have the access to the source code while checking. Under white box testing, we consider the following tests into them. So they are path testing, condition testing, loop testing, and we do the testing from memory point of view, and we test for the responses, speed, and the performance. These are the few advantages and disadvantages of the white box testing. Next, as discussed, black box testing is done by the testers. They do not have the access to the source code, and they do the testing from the user's point of view. And even this one has a few of the advantages and disadvantages as listed. Next, we see the differences between the white box testing and black box testing. So white box testing is done by developers and black box is done by our testers. So here they have the thorough knowledge of the internal design of the code under under white box, but under black box, no need to have the knowledge of the internal design and code. So it is suited for the algorithm testing, but white box is not suited for the algorithm testing. Next, we have the software life cycle. So here in the software life cycle, we have the few steps like requirement analysis, test planning, test design, environment setup, test execution, and test closure. Under requirement analysis, the entry criteria for the software and The business requirements are checked. Under test planning, it is first step in the testing process where they typically determine the effort and the cost required to do the project. Next, in the test case development, the testing team starts with the test cases development and activity here in this phase. So testers prepare the test cases and the test scripts and the test data. Next, we have the test environment setup. So here we do the phase where it is done in parallel with the test design phase. So the development team and the customer provide the test environment. Next, we do the test execution. So as a team, they start executing the test cases based on the planned test cases. Next, we have the test closure. This is the final stage where we prepare the test closure report, test metrics, and we do this based on the coverage, quality, time cost, software, and the business objectives. Next, we have SDLC, which is the software development lifecycle. So here also they're going to review the requirement gathering, they're going to do the analysis, and then the design, coding, testing, development, and this process repeats. So here the aim is to produce a high quality system that would meet or exceed the customer's expectations, and we make sure that it works effectively and the infrastructure and it is inexpensive to maintain and cost effective to enhance the features. So these are the few points which in detail giving us information regarding the requirement gathering, analysis, design, testing, and development and the maintenance phases. Next, here we see a few of the differences between the SDLC and STLC. So where we're going to see the differences in regards with the requirement gathering, design phase, coding, testing, and development or the maintenance phase. Next, we have the V model. So in V model, all the process occurs simultaneously. At the requirement stage analysis, the testing team starts writing the user acceptance testing. During the system design phase, testing team starts the system testing, and during the architecture design, they write the integration testing. During the module designing, they do the unit testing and coding. So this is one of the best practices that is followed in the industries as well. So here we have the stages as well depending on the complexity of the project. So here they have the high level designing, low level designing, writing the integration test, writing the test cases, and lots more. Everything is based on the complexity of the project. So we can see few here. Next, we have the levels of software testing. Under software testing, we have the main levels such as functional testing and non-functional testing. Under functional testing, we do the unit testing, integration testing, system testing, acceptance testing, and under non-functional, we perform the performance, usability, and security testing. So what is unit testing? Unit testing is testing in each and individual feature of a product. Say for example, you're using a bank application. There you're going to check the different features like the deposit, the credit score, and how we manage the payments and stuff. Next, we see the unit testing lifecycle. So here we're going to check all the data from the repository, and we do the changes, execute the unit test, and we fix if it has any defects, and then we review the code, and then we put the code back into the repository. This we do each and every time when an additional feature is added on to a software. So this we do it to make sure that the previous features are not affected by adding the new features to the software. Next, we have the unit test life cycle advantages and few of the disadvantages. So it becomes one of the disadvantages is it is a tedious process to write the to test each and every feature every time you're putting in a different feature to it. But one of the advantages is just in case due to the addition of a feature, if you have any bugs, it is very easy to determine the root cause, and we could fix the issue in the beginning stages before we proceed for the integration testing. And we would be talking about the integration testing here. Here it comes. Say for example, we have a module A and module B. So what we are going to do is we're going to check the functionality of both the interdependent between these two modules is working fine or not. So it is basically nothing but testing the data flow in between the two features. So that is what we call as the integration testing. So here we have just put up a small example to show it. Next, under integration testing, we have two types, and we are seeing in the flow chart how the division is made. We have the incremental integration testing and the non-incremental integration testing. And under incremental, we have top-down integration and bottom-up integration testing. So again, we have this integration testing depends upon the data flow is very complex, if it's difficult to identify who is the parent and who is the child. So based on the code requirement, we do the following. So here the example depicts an example when we are using the testing of the top-down incremental integration testing and the bottom-up incremental integration testing. Next, we are coming up to system testing. So system testing is testing the whole system and all the modules and components that we develop in the software. So this is done by integration testing, and it is a very important role in delivering a high quality product to our customers always, or our clients. Next, what is system testing? So system testing, we do the whole test as spoken earlier. Say for example, if we were considering the example of WhatsApp, they're going to check all the features such as posting your status and like how you hide the status for few of the people and the chat and so on. So whenever it comes, so system testing will be the first step in the software development lifecycle, whether the application is tested or not, and the application will be tested thoroughly to verify, to meet, and to check for the functional and the technical specification is fulfilled or not. Next, the user acceptance testing. So here we perform the end users and so here the user acceptance testing, it's done by the end users or the clients to verify or to accept the software system before we move the software completely to the consumers. So here they're going to check the satisfaction of the consumers, and they're going to see the learnability, efficiency, memorability, and for the errors. So here we have alpha testing, beta testing, contract acceptance testing, regulation testing, operational acceptance testing, and the black box testing. So alpha testing takes place within the organization to check and they're going to fix the issues. So beta testing, it is a version which comes before the original software is launched. Even we can be a beta testers for any of the app. We can register, we can download the app, and if we find any of the bugs, we can report it to the development team or the product owner. They would be able to fix the beta testing. Next, under non-functional testing, we have the performance testing. Here we check for the speed, scalability, reliability, and other stuff. Next, the performance testing. So here this is a flow chart which depicts the steps for the performance testing. We have different techniques that has followed in order to check the performance of a system. So we do the load testing, stress testing, soak testing, and spike testing. So load testing is nothing but conducting and understanding the features of how the system is going under a specific load. Stress testing is nothing but, say 100 users are willing to use the application, we are trying to put 150 users just to make that if it can withstand the stress. And soak testing is also known as an endurance testing, and it is performed to determine the system parameters and the continuous expected load. Spike testing is performed and by increasing the number of users suddenly to a very large amount and then measuring the performance. Say if 100 users are using and the servers would be supporting at the back end, so all of a sudden they're going to make the users from 100 to 200 and then they're going to check the performance just to check if there is a variation in the performance when there is a sudden hike in the when the customers are using the product. Next, we have usability testing. So testing the user friendliness of an application is called an usability testing. So here we can see the different, the phases that we follow. We plan, we choose the participants, we perform the test, analyze the results and documentation. Say an application that we're developing is on a gaming, so here we choose our participants to be youngsters most probably who would be using these applications. So depending on the application that we are developing, the participants are chosen and then the testing is done accordingly. So given below are some of the parameters where we're looking for the testing, that is for the speed, help, features, navigation should be simple, location of the components and compatibility. Next, we have security testing. This involves a software testing in order to identify any threats if we have for that particular application. So security testing is like very important feature. Say for you are using a banking applications, it's like really important to maintain the confidentiality, integrity, authentication and authorization of a particular app. So listed are the few of the features where we can see the attributes that is very important for security testing. Next, we have the software specification. So software specifications are nothing but giving the requirement and they do specify the details of each and every feature that has to be developed. So these are given on the below features. For example, the specifications will be based on the test oracle and the testing and the verification. And next, it might be based for the hybrid verification as well. Next, we do testing in the context of verification and validation. Now, what is verification and validation? Verification ensures that the software meets all the functional requirements, but validation ensures that the functionalities are met, the intended behavior, and this is done while we write the code. So we have the application of verification and validation for long-term projects, for complex application, or when a customer is expecting a very high quality product within the stipulated time frame. So we have few of the advantages of this as well. So it is listed below in the PPT. Next, what is a software failure? Software failure is nothing but having the defects or a bug in a software. Say if you wanted to transfer $100 instead of 100, if it's taking $10, so that's a defect. So those are the software failures and this has to be considered seriously and fixed as soon as possible. So it plays a very crucial role. So this defects might occur due to the wrong implementation or missing the implementation or extra implementation. Next, we have the OID. So OID is very helpful while we are developing a software. So this basically gives us the knowledge of how the sequence of the series of the parameters that we have to consider to develop, and this we use to write the UML. So for visualizing how the message flows in a system. So this helps in how to design and write a program basically. Next, as an example, let us see the user, order and the delivery. Say you place an order. Once you place an order, you will have to make a payment. Once the payment is made, you will get the confirmation of the payment and then your order is prepared and the order is served. So here basically we have the idea of how the work is flowing between the user, the order and the delivery. So this will give you an idea and the visualization of writing a code. Next, we have a traceability matrix. So traceability matrix is a document which has got the mapping between the requirements and the test cases. So we write the traceability matrix to make sure that every requirement has got at least one test cases, and we check for the deliverables if it contains the customer requirements, and we check if it has satisfied the project requirements. We check even for the missing requirements, and we do identify them, we do develop them, and make sure that we deliver the complete product to our team. Next, we see the advantages of traceability matrix. So it's going to ensure that we have at least one test case written for one of the features, and if there is a change in the requirement, we will be knowing the exact test case and the automation script to be modified. And we have the other uses also that you're seeing in the PPT. Next, usually who's going to write this traceability matrix? It's written by our test lead, and each and every test engineer will be filling the reports for each and every module, and they do write this one. Next, we have JUnit. So JUnit is one of the source frameworks that we are using to test our unit features. See, here we have the source, the web page, and the access, and the targeted language, and the lifecycle phases. Then we have the test phase. So this is one of the examples. So next we have the example of a code of how the JUnit is working. Maybe probably in the next PPT we have that. So here for testing doing the unit testing of a tool, so we have different tools like JUnit, NUnit, JMock unit, MR, PHP, and JTest. So one of the example that we are considered today is our JUnit testing. So this shows a simple example of the JUnit testing, and that's it. We are done for the day, and thank you so much, team.